Welcome to 5-3 Scale Factor and Dilation Notes. I'm going to talk about scale drawings. And scale models. Scale drawings are what architectures use to do a blueprint of a building, and models are used to replicate something that they're going to do later. They're used to represent objects that are too large or too small to be drawn or built in actual size. The measurements on a drawing or model are proportional. The word of the unit, proportional, to the measurements on the actual object. So this one is going to say measure the length of the objects in the table. So I'm going to do the bed, and I go 1, 2, 3, 4, 5, 6 in length. And then the dresser, 1, 2, 3, 4, 5. And then the rug, 1, 2, 3, 4, 5, 6. Okay, and and notice these are units, and so 1 unit is 2 feet. So 6 units would be, and you guessed it, 12 feet. And 5, if I put a 5 here, let's erase this and put a 5 here. And then 5 units. And then, so 1 to 2 I'm doubling, 5 double, that would be 10. We already did 6, which is 12. And it is a scale factor of 1/2, because we are doing units to feet. Determine the length of each model using the actual measurements below. And so I know my plane is 90 feet. So I'm going to match up my 90 feet. And I don't know how much my model is going to be, but I do know that 15 feet, notice my feet are on top, and my inches is 2 inches. And then I'm going to cross multiply, or I'm going to multiply the 90 by the 2 and get 180. And then 15x. Divide both sides by 15. And so my model is going to be 12, and I keep my units of inches. So when I am doing this, I multiply here by here, and I multiply here by here, and set the equation. Okay, my car, I have, let me erase this so I have some room for my car. I have 14 feet. I'm going to put my words, and I don't know what my model's going to be. And that's going to be 1 foot and half an inch. 2 ways I can do this. I'm going to say that if I go from here to here, to get to the denominator, I divide by 2. So I'm going to have to divide by 2 to get to the denominator, and that's 7 feet, or so, nope, not feet. Make sure you do your right units. That's 7 inches. The other way I could have done it, this is a different way. Same thing, same answer. I can multiply half of 14 equals 1 foot. So x times 1 equals 14 times a half. X equals, and that's multiplying, equals 7. Both times I get 7 inches. It's up to you how you want to do that. Okay, dilations. Remember, you get your eyes dilated at the doctor. Dilation means you can make things larger, or you can dilate things to make them smaller. And algebraically, in math symbols, you're going to take whatever coordinate I give you, and you are going to multiply it by your scale factor. And the cool thing about the scale factors is whatever number I give you tells you what you're going to do. So if the scale factor is less than 1, then I'm shrinking it, making it a reduction. If the scale factor is 1, I'm just making a copy of it. And then if the scale factor is larger than 1, then it's an enlargement. So if I tell you I have a scale factor of 2, since 2 is greater than 1, you know I'm enlarging something. If I have a scale factor of 0.5, that is less than 1, so that is a reduction. And then they try to trick us and say 120%. Well, that is actually 1.2, which is greater than 1, so that's an enlargement. So remember this right here, the given coordinates, this little k represents scale factor. So it says a figure has vertices at -1, 1, b is at 1, 1, c is at 2, -1, and d is at -1, 1. Graph the figure and the image of the figure after the dilation of scale factor. Compare the two figures with the scale factor of 3. Okay, so I'm going to do A is -1, 1, B is 1, 1, C is 2, -1, and D is -1, -1. And what did I tell you to do but multiply by the scale factor? Now my new guys are always having this little tick mark there. It's called A prime. And I multiply it by 3. So -1 times 3 is -3. 1 times 3 is 3. B prime, I'm taking the coordinate 1, 1 and multiplying it by 3, both of them. And then C prime is 6, -3, and D prime is -3, -3. So then I'm going to graph them. Let's graph in pretty purple. Pretty blue. Okay, so -1, 1 is right there. Oh, it is not. I did not do that very good at all. -1, 1 is right there, and that's my A. 1, 1 is there, and that's my B. And C is 2, -1, and that's my C. And then D is -1, -1, and that's my D. And so, when we are doing that, it becomes a trapezoid. That becomes a trapezoid from here to here. Oops. And here, and here. Trying to do it with my stylus and it doesn't work. Okay, so now I'm going to do my primes. We'll pick a different color. Let's go orange. Okay? So then negative 3, 3. That's A prime. And 3, 3 is B prime. And C prime is 6, negative 3. Is here, C prime. And D is negative 3, negative 3. And that's D prime. And I'm going to draw it. Scale factor larger than 1 enlarges. Now, if we counted the flats, not the diagonals, we could do that by the Pythagorean theorem. Okay, so I'm going to label this as 3. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 2. 1, 2, 3, 4, 5, 6. You notice that my 2 becomes 6 by multiplying by 3, and my 3 becomes 9 by multiplying by 3. And this is 2. If I multiply by 3, that's 6, and if you count it, it is 6. So that is how you scale factor. Okay, next one. We have J, K, L, and M. Graph the figure of the image after a dilation with a scale factor of 1/2. Compare the two figures. I already gonna know that it is a reduction by half. So I'm going to do J, K, L, M, and that's 0, negative 4, and that's 0, 6, and 4, 4, and 4, 2, and J prime, 0 times 1/2 is 0, half of negative 4 is negative 2, K, half of 0 is 0, half of 6 is 3, L, K prime, L prime, half of 4 is 2, half of 4 is 2, M prime, half of 4 is 2, half of 2 is 1. I think I have to replace the batteries in my smoke detector. I'll see if I can do that in the next couple of days. Sorry for the loud beep. Alright, 0, negative 4. There's my J. And K is 0, 3. Oops, sorry. K is 0, 6. L is 2, 2. Like a ballerina. Sorry, L is not 2, 2. I was looking at my prime. That would have messed me up. It's 4, 4. That's L. And M is 4, 2. And that's M. And here's my figure. It's another little trapezoid. And then we're going to do our primes. And so our primes are 0, negative 2. That's J prime. K prime is 0, 3. L prime is 2, 2. Little ballerina there. And M is 2, 1. And that's M prime. Connect the dots. Getting kind of squishy in here, but that's 2, that's 1, because half of 2 is 1. And if I count from J to K, from J to K is 10, and from J prime to K prime is 5. And the other ones we would have to do Pythagorean theorem. So the big thing is when you do this, when you work with